Hello everyone, welcome to my channel. In this video we are going to learn about the stacks data structure. So we know that data structure means it is a way of organizing the data, so in which a user can easily access the data. Okay, so here stack is a linear data structure. So similarly like array and linked list, this is a linear data structure. Okay, so here we can store the data in the linear format. So here the stack follows the LIFO rule, that is last in first out rule. So now in this video we are going to know about the what is the stack and what are the basic principles of the stack, what are the operations of the stack, that is like push and pop operations that we are going to perform on the stack, and stack using the array and stack using the linked list, and applications of the stack. Okay, so in this video on the stack, so we are going to know all these things. So first of all, coming to what is a stack. A stack is an abstract data type commonly used in most programming languages. So it is a named stack as it behaves like a real world stack. So here stack is an abstract data type. Okay, so this is used in the programming languages. It behaves like a real world stack. So these are some of the examples of the stack. That is stack of books, pile of plates, and stack of DVD or CD. Okay, so here we can consider the stack as a glass jar here. Okay, so we can consider the stack here. This is a glass jar and we are inserting some elements into the glass jar. Okay, suppose if you want to remove the first element, then you have to remove the elements that we have inserted last, right? Then only you can pick the first element, right? So I have to remove the third element, second element, and then first element we can remove, right? So you may get doubt that in the stack of books you may remove the book from middle of this stack, right? So that's why imagine the stack as a glass jar here. Okay, so you cannot draw the element from the middle of the elements here. So you cannot draw directly the second element, right? After removing the last element only you can remove the second element. Okay, so this is an example of stack. These are some real world examples of stack. So stack of books, pile of plates, and stack of CDs or DVDs. Stacking toys are also there, right? Stacking toys and bangles worn by women. So these are the examples of the stack. So this is a stack representation. So we have discussed that. So you can insert an element into the stack and then you can pop the element out of the stack, right? So here inserting the element is called as the push operation and removing the element from the stack is called as the pop operation, right? If you want to remove any element from the stack, we have to remove it only through the top only, right? So after removing the elements at the top of the stack, then only you can remove the elements. Suppose here I want to remove the third element. So after removing the fifth element, fourth element, then only we can remove the third element, right? So pushing is done like, so after first we are going to insert the first element, then second element, third element, fourth element, and fifth element. That means we are inserting all the elements here. So here the first element is in the bottom of the stack, right? And the last element that we inserted is at the top of the stack, fifth one, right? So if you want to remove the elements, then you have to use the pop operation. So for inserting the elements, we are using the push operation, and similarly to remove the element, we are using the pop operation. Okay, so we have to remove the, so suppose here I want to remove the element, the third element. So for that we have to remove first the fifth element, okay, and then fourth element, then only we can remove the third element, this one, right? So like this we can pop the operation, okay, perform the push and pop operations on the stack. So another thing here is we can apply this push and pop operations only at one end of the stack, right? So you can apply any operation on the stack only from one end of the stack, that is called as the top operation, top element, right? From the top of the stack only you can perform these two operations, right? So from this top only you can perform the push and pop operations. So stack can be implemented by means of arrays, structures, pointers and linked list. The stack can either be a fixed size or dynamic size. So these are some of the functions that we can apply on the stack. So pushing, popping, creating a stack and checking whether the stack is empty or full. Okay. So if you want to push an element, first we have to check whether the stack is full or not. Okay. So if the stack is already full, then you cannot insert a new element to the stack. Similarly, if the stack is empty, you cannot perform the pop operation, right? So if there is nothing in the stack, you cannot delete any element. So it results in the underflow. So this will result in overflow and underflow. Okay. So here for creating a for performing the push operation, we have to use this void push. So stack star s int element. So this is the star s is the pointer that points to the top of the stack. Okay, and element that we want to insert. Okay, so next one is int pop stack. So here star s is the pointer that points to the top of the stack, and void create stack star s. That means so star s is the pointer to the top of the stack. Okay, so now let us clearly know about the stack. That is the stack using array. So push using the stack. So whenever we are going to perform the push operation on the stack, then the stack is going to increment by 1, right? So here already an element is there here. So if we are going to again push some element to the stack, then the top is going to increment to the top of the stack, right? So it is going to increment the value by 1, right? So whenever we are going to apply the push operation, the top will get incremented by 1. Okay, because we are inserting new element to the stack, the top will get incremented by 1, right? Similarly here, if you are going to pop the stack, that means if you are going to remove the stack, right? So when you are going to remove the element from the stack, the top will decrement by 1 because we are removing from one element from the stack. So like this we can apply the push and pop operations using the stack with arrays. So next we will see how can we apply the stack using the linked list. So we are going to push the elements. So here we are instead of elements we are considering the nodes. Okay. So normally in the case of linked list, a node the linked list consists of a node with a link pointing to the next node, right? So in the case of the push using the linked list, so we can consider it like pictorially you can consider it like this. So first we are inserting an node here. Okay, so this will act as a header. Okay, this is the first node. So using the mloc function we are creating a node and inserting into the stack. So then again if you are inserting new node, then it will be inserted to the stack and this reference will be there here. Okay, the linked list first node will point to the second node. Again I am inserting another node. Okay, so this will point to the next one, right? So like this there will be link between the nodes. Okay, so push using the linked list. So whenever I am going to push the element into the linked list, the top element, that is the first node, will be in the bottom of the stack. Okay, and similar to the stack, so here the top will get incremented by 1. Okay, so this is the node with the link. So I am inserting 3 nodes here, 3 nodes with the links. Okay, so here, so there is a link between the first node to second node and the second node to the third node. Okay, so here the top is pointing to the top of the stack. That is the third element it is pointing. Okay, so whenever we are pushing the elements to the stack, so it will be stored in this format. Okay, so here top is pointing to the last node that has been pushed to the stack. So similarly here pop using the linked list. Okay, so here in the previous example we have inserted some elements to the linked list, right? So if you want to perform the pop operation, then the top will get decremented by 1, so it will point to the next one, right, previous one, and it will decrement this one. Okay, it is going to remove this node. That is the pop using linked list. So why we are using the linked list instead of the arrays, right? So for stacks, why we are using the linked list instead of the arrays? Means arrays is having the fixed size implementation, right? So we can declare an array of fixed size only. Okay, and we are going to keep a variable which always points to the top of the stack. It contains the array index of the top element. In the linked list implementation, we will maintain the stack as a linked list. So here a pointer variable top points to the start of the list, and the first element of the linked list is considered as the stack top. Okay, so these are some key points regarding the arrays and the linked list. So next we will see the how we will declare, create and push, and we can apply push and pop operations on the stacks using for both the arrays and linked list. So this is the declaration of the stack for the arrays and linked list here. Okay, so define maximum size 100 and structure LIFO. So using the structures for implementing the stacks. So stack maximum size. So here we are taking the maximum size as 100. That means in a stack we can store 0 to 99 elements, and the top points to the top of the stack. So how many elements are there in the stack? So based on it, the top will point. And type def structure LIFO stack. So we are defining the structure LIFO here and stack S. So this is the pointer that points to the top of the stack. Sorry, we can access the elements in the structure using the stack S. Similarly here for linked list also we are going to create a structure LIFO with the value and the next node, right? So with the value and the next node. Okay, so type def structure LIFO stack and the stack pointer top of the stack. So for stack creation, okay, so initially the stack will be always top equals to -1 only, right? The stack for the array, the top will be -1. If there is no value, then top will be like this. Okay, so top will be pointing to the -1 value. So it will be 0, 1, 2 and 3, right? So in this manner it will be storing the values. So the top will be pointing to the -1. That means so not to 0, and below it will be pointing because there is no element in the stack. And for creating a linked list, top equals to pointer top equals to null. That means in the given stack, so there is no node or element, there is no linked list node, right? So that's why the top will be null. The top will be null value. That means there is nothing in the stack. So now let us see how can we push an element at the stack. So in the case of the array, so the top equals to, so we are checking whether the top value is maximum size -1. So here I am taking a stack of size 0 to 5. The stack of size 5. That means we can store only up to 4 elements, right? So 0 to 4 we can store the elements in the stack. So S implies top equals to maximum size -1. That means if the top value is equals to 4, that means the stack will be full, right? So here the size is 5. If the maximum size is 5 minus 1, that is 4, then the stack is full. That means the printf stack overflow. Okay. Else we can push the element to the stack and then we can increment the top, right? So we can push some element to the stack and we can increment the top, right? So previously the top is pointing to this location, now it has moved to the top. Okay. For pushing an element into the stack in linked list. So we are creating a new node, right? So to push an element into the stack, so we have to push the node and its link, right? So we will create a new node using the malloc function here. So here the new pointer will point to the particular node. So if new equals to null, that means if the created new value is null, that means there is nothing in the node, then you can consider that the stack is full, right? Or else that means if the new node, there is some node in the linked list, then you can insert some value into the linked list and you can increment the, you can point the next to the top. Okay, so the top will be the new value. Next, for popping an element from the stack, that means for removing an element from the stack, so first we will check whether the top is equals to -1. That means if there is no value in the stack, then it will be top equals to -1. But if there is some value in the stack, then you can decrement the value by 1, right? So some values are there. So here the top is pointing to the second one. Okay, so here some value is there in the stack, that's why I'm going to remove the element from the stack and decrement the top by 1. So now the top will point to like this. Okay, so this is how the decrement popping will be performed. Suppose if there is no element in the stack, that means if the top is pointing to the -1, then stack underflow will occur. Okay, similarly for the linked list also we are going to consider whether the pointer top equals to null or not. That means top means, so here some values will be there. So here this is the top one. So here the top equals to null, not right. So here some value is there in the top. Okay, so that's why it will go to the else part and it will execute the else part and it will free the particular pointer p that is pointing to the top. Okay, so it will remove this particular element and pop it out and it will free the memory of the pointer p. So checking for the stack empty. Okay, so how can we check whether the stack is empty or not? So if S implies top equals to -1. Okay, so if the top value is -1, then the stack is empty. That will become true. So that's why I written 1. That means the stack is empty. Else written 0. That means the stack is not empty. Okay, so there is some value in the stack. So to check the stack is full or not, just reverse these values. Okay, so you check whether so you can check. So to check whether the stack is full or not, so we have to change the value here, maximum size -1. So we have to check whether the top equals to maximum size -1. So if it satisfies, then return 1 or else return 0. So for the stack is full or not. Okay, to check whether the stack is full or not, so the stack maximum size is maximum size -1, right? So we have to check that one. So equals to maximum size -1 means the stack is full or else it is false. So this is a simple example regarding how can we apply the stack using an array. So here the maximum size of the stack is 100. Okay, so here I am declaring the top. Okay, so create address of A and address of B. So these are some of the applications of the stack, that is expression evaluation, conversion, recursion, factorial, quicksort, and towers of ANI and activation record management. So these are some of the applications of the stack. We will see about the applications of the stack, that is expression evaluation and conversion, in the next video. So thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.